Oh, hello, quants friends. Welcome to Stochastic Calculus for Finance 1. And this is section 6.2, where we're continuing to talk about the binomial interest rate model. So in the previous videos, what we did was we were able to introduce what this thing was, the binomial interest rate model. And now in this video, I want to give first a concrete example to show how we can use now this binomial model that we have introduced to price very simple instruments such as the zero coupon bonds. So let's get going. So this is where we had from our previous videos, right? We introduced this binomial, this tree. We showed how it was dependent on coin tosses, and finally we also had these terminal probabilities, right? Here are the terminal probabilities that we have here, and from these terminal probabilities, what we were able to do, we were able to get to construct these transitional probabilities from one state on the tree to another state, like that. So now in this, what we're going to do now, we're going to, for each of these states, we're going to say what exactly the interest rate is. So maybe here the interest rate is 1%, here the interest rate is 2%. And to do this, I will use an example from the book. And basically, specifically, the example in the book is based on example 6.3.9. So this is what the tree looks like. We have still the traditional probabilities. And at the beginning, interest rate is equal to 0%. And then for the next period, we're going to flip the coin. If the coin is a head, interest rate move to 1 divided by 6%. If interest rate is basically if the coin flip is a tail, then interest rate will be equal to this one. And here we have like this value of interest rates for each of the different states on the tree. And what we want to do here is we want to be able to use this to price basically a zero coupon bond that's maturing at time 1. So for example, let's say we have a zero coupon bond and that pays $1 at time 1. We want to find its value as of today. We can also try to see how we can use this to value a zero coupon bond that pays maybe $1 at time 2 and try to find its value today. So naturally what we're going to do is we're going to discount, right? Discount twice. So here we're going to discount at R1. Here we're going to discount at R2, R0, sorry. And then we have B03, which is the price of a zero coupon bond that's paying $1 at time 3. And we want to find his price as of today. So naturally what we're going to do is going to discount here. So this is going to be discounting based on R2, then discount based on R1, and then discount based on R0, right? And then we'll try to be even more, do more interesting thing actually. So let's say we want to find the price as if you're standing at time 1 of a zero coupon bond that's paying $1 at time 1. Well, that's just one. So this is fairly trivial. But then we can try to use this also. Think, okay, we're standing now at time 1, and we see that there's a zero coupon bond that's paying $1 at time 2, and we want to find its price today. So again, we're just going to discount, and same thing also here. Try to just discount it here. So this is what we're going to do in this session. So note that for these bonds, all these bonds that I'm talking about, we only care about the first 2 coin toss, right? Because for example, R0 is not random. If you go to the bank today, they can tell us what the interest rate is. And then to be finding the interest rate from R1, from time 1 to time 2, we're going to flip the coin. So that's going to be R1, the first coin toss. We use the first coin toss. And then after the second coin toss, then we know R2. So we know basically the main variable that I needed to be able to price these zero coupon bonds. So that is why here we just really care about the first 2 coin tosses. So what that means is like all these states here, well, they are just making the tree bigger for nothing, at least for our purposes. So what we can do is really just remove them, and then we focus on this tree here, right? So let's try to do this. And to be able to compute these bonds, we'll need essentially this table. So let's go through this table so we can understand what it means. And so this is P tilde here. Let's try to go to this table and see if we can understand this table and how it can help us to price this zero coupon bond. So let's look at the first thing here. So what are we trying to do here is just finding basically this expression 1 divided by 1 plus R0. If you look well, this is just the discounting of the discounting amount. So we are at time 0, we are at time 1. If you want to be able to discount here, discounting, we just multiply by 1 divided by 1 plus R0, right? And R0, the interest rate is 0%, right? So when we get a head or tail or whatever it is, this is always 0, so you just get 1 here. And this is also take us back to what we said earlier in our previous video, that R0, when you look at the interest rate process, R0 is really not random. So at every time step, no matter what the coin toss is, R0 is going to be 1. That's what it is here. So now let's look at R1. So the value of R1 are going to change because R1 depends on the first coin toss, right? So if the first coin toss is a head, then R1 is 1 divided by 6. If the first coin toss is a tail, then R1 is 2 divided by 5, right? So we need to take this into consideration now. So, okay, so here we see the first coin toss is a head. So if the first coin toss is a head, that means this R1 is equal to 1 over 6. So this amount here is just 1 divided by 1 plus 1 over 6, which is simply um, 1 over 7 divided by 6, which is 6 divided by 7. And that's what we have here. And naturally, for HT, well, the first coin toss is a head, so we're still in here at the stage, so same thing. And if it's a tail, then R1 is equal to 2 over 5. So you replace this R1 here by 2 over 5, and you'll be able to get the value here, right? So that's pretty much what we have here. Then we'll move next to R2. R2, so when you have both HH, that means R2 is equal to 1. So that means we replace this guy here by 1, right? And then we have 1 over 2 that we are seeing here. Now, if you have a HT, so that is we are here, then R2 is equal to 0. So we replace this by 0, and we have this simple 1. And we can do that also for these other guys. Now let's look at D1. What is equal to D1? So if you remember the definition of this D's, it's just like 1 divided by 1 plus R0. This is what all D1 is, right? So 1, we divided by, so we actually computed that already here, right? So this is just 1, so we just repeat that here. So what is D2 now, if you want to compute D2? Well, D2 is nothing but is this expression, right? So we take these two and they're multiplying each other. So that means then I just take this guy multiplied by this guy multiplied by this guy multiplied by this guy. So you have 6 divided by 7, 6 divided by 7, 5 divided by 7, etc. Right? So nothing too deep there. And now we move to D3. D3 is just these 3 elements multiplied by each other, right? So we take this guy multiplied by this guy. And when I compute that, what I find is this 3 over 7, right? And then I do the same thing with here. Then you find this 2 over 6 over 7, etc. Now finally, we interested in the probabilities, right? Those kind of probabilities. So here we want to find what is the probability of getting head and head. Well, we know the probability of getting head and head is just the probability of going through this path here. And we know that the probability, this probability here is 1 over 2. And then multiplied by this amount here, we're going to get 2 over 3, right? So 1 over 2 multiplied by 2 over 3, that is just this 1 over 3 right here. Right, so 1 over 3. And then the same thing, 1 over 6, it's just the probability of going through this path. So this is getting 1 over 2 multiplied by 1 over 3, and we're getting this 1 over 6 right here. And we do that for all these these elements here. So very simple stuff. And now this table is going to be really the basis of on what we're going to be using to really be able to price these zero coupon bonds. So let's start then. Let's start by computing the price of a zero coupon bond that maturing at time 1. Well, that is the expected value under the horizontal rule of D1, right? As we stand of D1. So that's very simply. So let's see, what is D1? This is D1s. What is the probabilities? This is it. So when we do some type of like product between these two, we just find one. Well, and that's natural because D1, no matter what the coin toss is, we're just gonna get a 1 here. So nothing too mysterious there. So let's try to find now B02. The price when you're turning at time 1, what is the value of a bond that's maturing at time 2, right? So this is just the expected value of this D2 factor. And so we see what these D2s are, and we see what these probabilities are as well. So again, we can just do this multiplication. So that is just 6 times 1 over 3. 6 divided by 7 times 1 over 3. And that is very simply just this guy multiplied by this guy. And then we can see here is just again this guy multiplied by this guy, and etc. And you will find the value here of this bond. Then finally, if you want to find B03, that's just the expected value of D3. We know the value of the values of D3s, we know the probabilities, we just do the sum product, and we will get essentially the value there. So as you can see, pricing on this tree is very simple once you have done the computation for this table. And we can do the same thing, for example, for B1H, for example. So this is essentially now this is time 1 and this is time 2. The bond matured at time 2, and we want to find its price as if we were standing at time 1. And we know that the first coin toss was a H, right? So essentially the first coin toss was a H. We're standing here, and we want to find the value of a bond that matured at time at time 2. So this is just the expected value of D2, right, as of time 1. And we have seen how to do this before. So if you're standing at time 1 here, we want to find the expected value of D2. We know the transitional probabilities. We know the different two states that D2 can take. So D2, if the first quantum is a head, then D2 is going to be at one of these two values here, right? And we know the transitional probabilities. We know that the transitional probabilities of getting HH is basically 2/3, and the probability of getting HT is 1/3. So we can essentially do the math here, right? So this is just a D2 in the case that we have HH, times the probability of getting another H, given that the first coin toss was a H, right? That's what this is telling us. Plus the probability, the value of D2 under this state, HT, times the probability of getting a tail, given that the first coin toss was a head. And naturally, as you guys said before, so we know the transitional probability 2/3. There's this 2/3 that we're seeing here. We know the transitional probabilities of getting a tail is here, and we know the value at each state essentially. So very simple stuff. You get your 6/7. And we can do the same thing with this value time here. This is the expected value as of time 1, as we talk at time of D3H, all right? So that is essentially the probability of getting a HH. So let's plot this so we can be able to see. So we have 0 here, 1, 2, and 3. So you want the probability of a zero coupon bond maturing at time. We want to find the value of a zero coupon bond maturing at time 3 as of time 1, right? So what we need to do then is we need to take this guy here and then discount it here and discount it here, knowing that the first coin toss was a H essentially. Okay, so that means we need to find R2 and we need to find R1. Okay, let's see how we can do this one then. So we said this is the probability of D3HH, right? So because this is just the expectation of D3H, so this is the probability of D3HH, and we can also get a D3HT, right? So D3HH, D3HT, these are the values. And the probability of getting an H, given that the first coin toss was a H, right? That's what we're multiplying by this amount here. So this is just the two-thirds that we have seen before. So it's not actually, it's very simple as well, right? It's kind of just the same operations. And then we can compute this value also, which is just expectation as of time 1 of D3 T, when we know the first coin toss was a T. So the first coin toss was a T. So we're interested in these two cases. We're looking the expected value of D3. D3 is this value here. And to compute this, we will need the probability of getting a H, given that the first coin toss was a tail. And the first coin toss was a tail, probability of getting a H is one half, and the other one is 1/2 also. And you can easily do the computation as well and find the values. So I think this is all I want to show in this video. Hopefully this is helpful. Thank you.